Howdy, howdy. So this is my last day of isolation. And so that means the next time, if you're watching the video again, that means that either you were absent, you're in isolation, or something else. So this is going to be a trig practice day. Like I said last week, we're doing a lot of trig in this unit. That's why I hated that I had to be out this week, because it's a lot of trig. But that's okay. We're going to hit it again today. And then you'll have the weekend to let it kind of just soak in. And then when you come back, we'll review and test. So let me share my screen and we shall begin. Okay. So trig ratios again. Just to kind of help us start off, we used the acronym Sohcahtoa to help us remember our trig ratios. But what does Sohcahtoa really stand for? Sounds like an Indian name, but it's not. It stands for the sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is the opposite leg divided by the adjacent leg. That's what Sohcahtoa is short for. It helps you to remember your trig ratios. So which trig ratio is defined as the opposite leg over the adjacent leg? Well, which one did we just write? Opposite over adjacent is tangent. Okay, number 3, which trig ratio would we use to determine the value of x? So here it's just asking for which trig ratio. We don't have to solve it, but we're going to start it as if we were. So let's say we wanted to actually find x. That's that side. Make sure to label your legs. And then circle the angle they give you. So how is the x related to the angle they give us? It's across from it, so that means it's our opposite. And then what about the 16? 16 is across from the right angle, so it's our hypotenuse. So which trig ratio deals with the opposite and the hypotenuse? That would be sine. Again, we don't have to solve this. It's just asking which ratio would you use? You would use sine. That's all we had to say here. Okay, number 4. Write each trig ratio as a fraction and as a decimal to the nearest hundredth. Okay, for the first one, they ask us about the cosine of t. Well, so I'm going to be standing at t. Well, if I'm at t, hang on, let me back up. If I want cosine, what two sides do I need for cosine? I need the adjacent over the hypotenuse. So if I'm at T and I label my legs, Which leg is adjacent to T? What's the length of it? 15. This is adjacent to angle T. So our top number is going to be 15 over, and then which one's the hypotenuse? So one across from the right angle. So that would be the 17. 15 over 17. So then I'll take that and I can put that in my calculator. 15 divided by 17. I get 0.88. Okay, then it asks for tangent of angle I. So now I'm going to be up here at I. If I want tangent, what do I need? I need opposite over adjacent. So if I'm at I, which leg is opposite of where I'm at? That would be the 15. So 15 goes on top over. Which leg's adjacent to angle I? That would be the 8. So 15 over 8. (1.88) in this case is our tangent. And then we're still at angle I, and we want to do the sine of angle I. So remember, sine is opposite over hypotenuse. So for opposite of angle I, we already said that was 15. And then what's our hypotenuse? 17. 15 over 17. Hey, we had that one earlier, but it's still going to be 0.88. Okay. So now they want us to use the trig ratios to find each length to the nearest hundredth. So for number 5, they ask us to find AB. Okay, so there's the one we're finding. Here's our leg, here's a leg, and then here's the angle they give us. So the side we want to find, how is it related to the angle they give us? AB, that's going to be our hypotenuse. What about the 8.4? The 8.4 is adjacent. So which one uses adjacent and hypotenuse? That would be cosine. So set it up. Cosine of 23 equals 8.4 over x. Multiply by x on both sides. You're going to have x times the cosine of 23 equals 8.4. Divide by the cosine of 23. Those cancel. You get x equals 8.4 over the cosine of 23. Now at this point, we can take it and type it into our calculator. But remember, we need to make sure our calculator is in degrees. So if I'm looking at my scratch pad, I look in the top corner, it says radians. I don't want radians, so I'm going to click it and change it to degrees. Now I can type in what I need to. So 8.4 divided by the cosine of 23. 9.13. And it looks like we're in inches. So 9.13 inches. Okay, so now they want us to find AC. They want us to find AC. So I'm not going to need the hypotenuse anymore. I still need the adjacent. But now I want AC. How does AC relate to the angle that's given? It is opposite. So which one uses opposite and adjacent? Tangent. So set up an equation. Tangent of 23 degrees equals x over 8.4. Multiply by 8.4 on both sides. The 8.4 times the tangent of 23 equals x. So we can type that in the calculator now. 8.4 times the tangent of 23. 3.57. So this means that this is 3.57 inches. That's how long AC is. Okay, so 7 and 8, we're doing the same thing, same process. Just different picture now. Let's see. They want me to find XY. Let me label my legs. Circle the angle given. Now, the 16.3 that they gave us, what side is that? That's our hypotenuse. The XY that we want to find right now, what side's that? That's the adjacent. So which one uses adjacent and hypotenuse? Cosine. So I'll do the cosine of 62 equals the adjacent. I don't know it, so I'm going to call it x over 16.3. So multiply both sides by 16.3. Those cancel. 16.3 cosine of 62 equals x. Now, I could type this in. X is by itself, I could type it in. So 16.3 times the cosine of 62. 7.65. So this side is 7.65. Okay, next they asked me to find YZ. So now I'm going to be down here. YZ. How does YZ relate to the angle that's given? It's opposite. Which one uses opposite and hypotenuse? For opposite and hypotenuse, that would be sine. Okay, so we want to do the sine of our angle. The sine of 62. I don't know the opposite, but I know the hypotenuse is 16.3. So multiply on both sides by 16.3. Cancels out over here. We're going to have 16.3 times the sine of 62 equals x. Then we could type that in because x is by itself. $14.39. So YZ is 14.39. Right? Yeah. Okay. I'm going to kind of draw like a little line through here to kind of break these up. There we go. Okay. So that's to find the length. So now on these, so again, we're finding each length, or we found each length. Now they want us to find the angles. So when they have us do normal lengths, this is just a normal ratio. Remember, angles mean we need to do the inverses. So first, they want us to find angle A. Angle A. Well, we can pick any two sides that we want to pick. Maybe, 25 is the hypotenuse. So maybe you want to, since you know that, you're going to say 25. And then, these are legs. So 24 is touching A, so we're going to say that's the adjacent leg. Which one uses adjacent and hypotenuse? Cosine. So I need to do the cosine inverse of 24 over 25. So the cosine inverse of 24 divided by 25. Nearest degree would be 16 degrees. Now, you didn't have to pick that one. You could have picked 7 over 25 and done sine. You could have done 7 over 24 and did tangent. There's different ones you could have picked. Okay, so we know A is 16 degrees. This right angle means it's 90 right here. So I could actually say, well, to get C, I'll do 90 plus 16. Gives us 106. And then subtract that from 180. And that's going to get you 74 degrees. So measure of angle C has to be 74 degrees. And we could verify this with an inverse trig ratio. Now doing C, 24 would be the opposite. 25 still the hypotenuse. So let's do the sine inverse of 24 over 25. 74 degrees, just like we found. So we're good. You don't have to do trig, but on one of them. Okay, let's look at the next one. We're still finding angles, just like we did on 9 and 10. So first angle they want us to find is angle R. Again, I do not care which two sides you use, since they give us all three. I'm going to use the opposite and the adjacent. But why? Because those are the two I want to use. Opposite and adjacent. So which trig ratio uses opposite and adjacent? Tangent. So I want to do the tangent inverse of my opposite, which is 10, over the adjacent, which is 24. I'm going to do the tangent inverse of 10 divided by 24. So you give me 23 degrees. For R. R is 23 degrees. This box means this angle is 90 degrees. So now we just have to find S. Well, we could do trig again, or we could say 90 plus 23 gives us 113, and then subtract that from 180. And let's see, that gives us 67. So measure of angle S is 67 degrees. Okay. $13 to the nearest whole number. What is AB? What is AB to the nearest whole number? Well, I'm going to highlight the side I want. And then I'm going to label my legs. There's a leg. There's a leg. And then let's circle the angle they give us. So the side I want, how is it positioned in regards to my leg? So it is adjacent. And what about the hypotenuse? Oh, what about the 4? I just totally gave that away. The 4 is our hypotenuse. What about the hypotenuse? You just gave them the answer. 4 is the hypotenuse. So, which one uses adjacent and hypotenuse? That would be cosine. So let's set it up. The cosine of your angle is equal to the adjacent, which we're going to just call x, over the hypotenuse, which is 4. 4 is on the bottom, so multiply by 4 on both sides. Cancels right there. We have 4 times the cosine 32 equals x. X is by itself, so we can plug it in. Get 3.39. But we got to be careful because it says to the nearest whole number. So 3.39 rounds to what? It rounds to 3, and it looks like we're in inches. Okay, 14, to the nearest whole number, what is QR? There's the sign we want. Label our legs. Circle the angle given. Let's see, the sign we want, how is it positioned in regards to what we want? In regards to what we're given. So how is QR, the one I highlighted, positioned in regards to the angle? It's next to it, right? So that means it is our adjacent. What about this 8.1? It's opposite. So which one uses opposite and adjacent? Tangent. So the tangent of 40 equals 8.1 over x. Multiply by x on both sides to get rid of the x on the bottom. I have x times the tangent of 40 equals 8.1. Divide by the tangent of 40. Those cancel. So x is 8.1 divided by the tangent of 40. Let's type that in. 8.1 divided by the tangent of 40. Calculator gives us 9.65. But they ask us to go to the nearest whole number. So what whole number is closest to 9.65? 10. This is going to be 10 meters. Okay. Okay, so 15. After seeing the pretty ramp that Tommy, Joe, and Daisy Mae made, John and Paul asked them to update the ramp at the Angelina County Airport. They want a ramp that's 12.2 feet long and makes a 2.6 degree angle with the ground. So let's draw us a picture here. So the ramp itself is 12.2 feet long. And then this angle right here is 2.6 degrees. So the nearest hundredth of a foot, how high is the ramp? So how tall is it right here? That's what we want to find. That's our X. And here's our right angle right here. So if we circle the angle they give us, how is this X positioned in regards to the angle given? It's opposite. What about the 12.2? It's going to be adjacent. No. Opposite, yes, but not adjacent. Why did I say that? I said that because I didn't label my legs. That's not even a leg up there. That's our hypotenuse. That's why you need to label your legs, because you can make mistakes like that. Hypotenuse. Okay, so what's opposite in hypotenuse? Which trig ratio uses that? Sine. So I want to do the sine of 2.6 equals the opposite, which is X, over 12.2. Multiply both sides by 12.2. Those go away. We're at 12.2 times the sine of 2.6 equals X. Is X by itself? Yes. So let's type this in our calculator. 12.2 times the sine of 2.6. 0.55. So to the nearest hundredth, it's going to be 0.55 feet. That door is not very tall then. It's only half a foot up in the air. Well, turns out that this ramp's not going to work. They really need a wheelchair ramp that makes a 5-degree angle with the ground, because the door is 18 centimeters above the ground. Okay, so let's draw a triangle here. Again, here's our right angle. Label what they give you. And you have 5-degree angle right here. The door is 18 centimeters above. They want to know the horizontal distance covered by the ramp. So that's the side-to-side distance. Okay, so circle your angle. And gosh forbid, don't forget to label the legs. Okay, so how's this 18 positioned in regards to the 5 degrees? It's across from it, so it's opposite. What about the horizontal distance, the side we want? That's going to be adjacent. So which one uses opposite over adjacent? Tangent. So the tangent of 5 degrees equals the opposite over the adjacent. You want the adjacent, so multiply both sides by x. X is on the bottom. So x times the tangent of 5 equals 18. Divide by the tangent of 5. Then we get x equals 18 over the tangent of 5 degrees. $18 divided by the tangent of 5 degrees. $205.74. Says hundredth of a centimeter. So 205.74 centimeters. Okay. So that sounds like a long ways, and this is kind of just a side note. Like, my gosh, that's a long ways. But keep in mind that it's about 30.5 centimeters in a foot. So if you divide that by 30, it's only about 6 feet 9 inches. So 6.75 feet. That's not really that far of a ramp. That's actually a pretty steep ramp. They better be holding on. If it's a wheelchair ramp, they better be holding on to their wheelchair coming out of that, because they're going to go whoo, down that ramp quick. Hold on to your wheelchair. You'll be off to the races. Okay. John Paul sights Mary Beth's plane at an angle of elevation of 56 degrees. Okay, so let's see here. John Paul's right there. It says his angle of elevation. Remember, elevation means up. So here's JP down here. This angle is going to be 56 degrees. So he finds her, Mary Beth, up in her plane. And she reports her altitude is 4,132 feet. Find the horizontal distance between the plane and the airport. So they want the bottom down here. Well, here's your right angle. So let's see, label your legs, just like we've done. So there's a leg, there's a leg. Circle the angle given. How does the 4,000 and something compare to the angle? It's opposite. What about the horizontal distance that we want? It's adjacent. So which one uses opposite and adjacent? Tangent. So that means we're going to do the tangent of 56 degrees. It's going to be 4,132 over x. Okay, so solve for x. We have to multiply by x on both sides. It's going to be x times the tangent of 56 equals 4,132. Divide on both sides by the tangent of 56. Those cancel. We're going to have x equals 4,132 over the tangent of 56. And I'll need that to the nearest foot. (2,787 feet). Okay. Last one. Mary Beth is flying her plane at an altitude of 1,500 feet. She sights Abe Morton Stadium at an angle of 37 degrees. What is Mary Beth's approximate horizontal distance? Well, let's think about this. If she's flying, so here she is up in the air. She's going to have to look down at the stadium. So she's going to be looking down. Down here is going to have to be the stadium. Okay, so there's my right angle. It says 37 degrees. And our altitude's at 1,500 feet. They want to find the horizontal distance to the stadium. So basically, we're finding the dotted line here. That's going to be our x. So let's not forget, label our legs. And then circle the angle that's given. Except don't circle it and cover it up. Way to go. Okay, so how does the 1,500 that's given relate to the angle? It's opposite. How does the side we want relate to the angle? It's adjacent. So which one uses opposite and adjacent? Tangent. So we're going to have the tangent of 37 equals the opposite, which is 1,500, over x. Okay, so multiply by x on both sides. And x times the tangent of 37 equals 1,500. Divide by the tangent of 37. Those cancel. We get x equals 1500 over the tangent of 37. So put that in the calculator. Right. 1,991, because we got around to the nearest foot. So it's going to be 1,991 feet. That's how far she is horizontally from the stadium. Okay. So there's the notes. Remember that today is a practice day. So since today's a practice day, there's not going to be any guided practice. Your notes should look just like your assignment. Notes and assignment should be pretty similar. So if you have any questions, please don't hesitate to email me to ask me. Hopefully I'll be back in the classroom on Monday. But remember, you are awesome and you were created to do great things. Always believe.